In section 10.7, we'll be solving linear inequalities. Okay, inequalities are less than, greater than symbols. So a few rules that we're going to discuss before starting to solve inequalities are, number one, a parenthesis indicates that an endpoint is not included in a solution set. So in other words, if you have less than or greater than, you'll use parentheses. A bracket indicates that an endpoint is included. So that means less than or equal to, greater than or equal to, we use brackets. So the parentheses like this, brackets are the squared ones. Okay, number 3, a parentheses is always used next to an infinity symbol, which is negative infinity or positive infinity. You always use parentheses, no matter what the inequality sign is. And number 4, the set of all real numbers is written in interval notation as negative infinity to infinity. And we'll do some examples so you can see exactly what that means. Alright, so in example 1, we're going to practice graphing on a number line and writing an inequality in interval notation. So usually in your book it asks for the interval notation first and to graph it afterwards, but it's actually easier if you do it the opposite way. So I always graph it first. So for A, x is less than or equal to 3. Okay, so here's my number line. Less than or equal to 3, if that means that the 3 is included, so if it's less than or equal to, then it's a bracket, and less than is to the left, and you're going to shade the arrow. Now the arrows represent infinity and negative infinity, so to the left is negative infinity, and to the right is infinity. So once you've drawn it on the number line, your interval notation is going to be exactly what your number line shows you. So it's going to be negative infinity, and we always use parentheses for infinity, and then 3. And if the 3 has a bracket on the number line, it's going to have a bracket on your interval notation as well. Right, B, x is greater than or equal to negative 4. So x is greater than negative 4, that means that it's going to be a parentheses and shade greater, which is to the right. Everything greater, including the arrow. So remember, the arrow represents infinity. So my interval notation is going to look just like my number line. Parentheses, negative 4 to infinity, and infinity always has parentheses. Alright, C. Negative 3/4 is going to be close to negative 1. Okay, and its x is less than or equal to negative 3/4. So it's going to have a bracket, and less than or equal to will shade to the left. The arrow represents negative infinity in this case. So my interval notation would be negative infinity to negative 3/4, and negative 3/4 has a bracket. Alright, example 2 is the same directions. This time they have the variable on the left side. What I like to do is switch it. I like to have the variable on the left side all the time. So I'm going to rewrite a x, and then the inequality symbol is going to have to flip too. So less than or equal to negative 4. So no matter how it's written, the inequality symbol is pointing to the x. The smaller side is to the x. The bigger side is to the negative 4. Okay, so now I can draw my number line. I'm going to have -4 somewhere on it. And then less than or equal to is a bracket. Shade it to the left, including the arrow. Arrow represents negative infinity, so my interval notation is going to be negative infinity to -4. -4 has a bracket. Okay, with B, I'm going to switch it just like I did with A, so I'm going to have x is greater than 0. So notice that it's pointing to the 0 in both ways that it's written. It's always open to the x. So my number line, I'll have 0. X is greater than 0, so there's going to be a parentheses because it's not equal to, and everything greater, which is to the right, including the arrow. The arrow represents infinity, so then my interval notation is going to be parentheses 0 to infinity, and infinity also always has parentheses. Alright, example 3 has what I call between statements. So if you look at A and B, both of them have an x in between two numbers. So I'm going to draw my number line, and I have -7 and 2, and x is going to be everything between them. So notice that both of these are less than symbols, so they're both parentheses, and you're going to shade between the 7 and the 2. So the reason is, if you read x is greater than -7, so greater is this direction, and x is less than -2, less than is this direction. Okay, so it goes through everything between those two. Alright, so then interval notation would be just what the graph shows me, -7 to 2. Okay, so on B, x is between -6 and -4. So -6 is less than, so that's parentheses. -4 is less than or equal to, so that's brackets. And shade everything between them. So then my interval notation is going to look just like that. -6 with parentheses, -4 with a bracket. Alright, so those first 3 examples just showed us how to graph them. Now we're going to solve them, and then once we solve it, then our answer is going to be written in interval notation and graphed on a number line. Alright, so I'm going to solve it the same way I solve equations, using the balance method. So I need to cancel r from one side, so I'm going to put -7r on both sides. So 8r minus 7r is 1r. Bring down my -1 and my 2. So then add 1 to both sides to cancel the -1, and that gives me r is less than 3. Okay, so I can draw my number line. If r is less than 3, that means I have a parentheses, and I'm shading everything less than, which is to the left. The arrow represents negative infinity, so my interval notation would be -infinity to 3 with parentheses. Alright, so on B, I'm going to add 4/3 to both sides. So notice that the other side, the 4m, is not a like term with 4/3, so I'm going to add the 4/3 to the side. So then I have 5m is less than or equal to 4m plus 4/3. So now I need to cancel m from one side, so I'll subtract 4m, and that'll give me 1m is less than or equal to 4/3. Alright, so 0, 1, 2. 4/3 is a little bit bigger than 1 whole. It's 1 1/3. And it's less than or equal to, so it's going to have a bracket and shade everything less than, which is to the left. In this case, the arrow is negative infinity. So my interval notation would be negative infinity to 4/3, 4/3 having a bracket. Okay, for example 5, it says multiply each side of negative 2 is less than 8 by 6, and then by negative 5. So we're going to start with the inequality negative 2 is less than 8. So that's a true statement. Now we're going to multiply both sides by 6. So negative 2 times 6 is negative 12. 8 times 6 is 48. Negative 12 is less than 48. That's still true. Alright, so let's look at what happens when we multiply by negative 5. So, original statement, negative 2 is less than 8. Multiply by negative 5. Negative 2 times negative 5 is positive 10. 8 times negative 5 is negative 40. So now notice if I have 10 less than negative 40, that's false. So I have to switch it and put 10 is greater than negative 40. This happens when you multiply by a negative number. Multiplying or dividing by a negative number to both sides of the inequality. You have to switch inequality symbol to the opposite direction. Okay, part B is a similar example. So multiply each side of the inequality negative 4 is greater than negative 9 by 2 and then by negative 8. So when we multiply by 2, okay, negative 4 is greater than negative 9, that's true. Then negative 4 times 2 is negative 8, is greater than negative 18, and that's true as well. Okay, so you can look at a number line to verify. Remember, the further you go on the negatives, the smaller the numbers are. So negative 4 would be closer to 0, negative 9 would be further away, and then negative 8, say, is over here, negative 18 would be way down there. Alright, so now we'll multiply by negative 8, so negative 4 greater than negative 9. Again, that's a true statement. And then we'll multiply by negative 8. So negative 4 times negative 8, negative times negative is positive 32, is greater than positive 72. 32 is greater than 72. That is false. So in order to make it true, we have to reverse the sign to say less than. Okay, so again, that goes back to our rule that says anytime you multiply or divide both sides of an equation by a negative number, you have to reverse the inequality symbol so that it faces the other direction. Okay, so this is just a summary that comes straight out of your book for any real numbers A, B, and C. If C is positive, then you can multiply it to both sides of the inequality, and it has the same solutions. If it's negative, you have to switch the inequality symbol. So notice that it was less than. When you multiply a negative to both sides, you switch it to positive. Alright, so example 6. Remember, we're using the balance line just like if it was an equation. So 9 times x is less than negative 18. Divide by 9. Now in this case, I have a negative 18, but that's not what I'm doing to both sides. I'm dividing by a positive 9 to both sides. So if I divide by a positive, that doesn't change anything. So my inequality symbol is still going to be less than. And negative 18 divided by 9 is negative 2. So don't get it confused between what your answer is or what part of the problem is. You always look at what you're doing to both sides. If you're multiplying or dividing by a negative on both sides, that's when you switch it. So in this case, it'll stay the same. And so when I graph it, I'll have a negative 2. It's less than, so I'm going to have a parentheses and shade everything less. And then the arrow represents negative infinity, so the directions don't say it, but just for the extra practice, because most of the problems will ask you in your homework to write in interval notation, so that would be negative infinity to negative 2. Alright, on B, this is negative 2 times r, so we'll divide by negative 2. Now when I divide by a negative, that's when I flip the symbol. So then I have r, and then it switched from greater than to less than, and then negative 12 divided by negative 2 is positive 6. Graphing that, less than negative 6 would give me a parentheses and everything to the left. The arrow represents negative infinity, so my interval notation would be negative infinity to 6, both with parentheses. Alright, and then C, negative 5 times p is less than or equal to 0. Divide by negative 5. Anytime I divide by a negative, I should automatically go ahead and switch the symbol. So then that gives me p is greater than or equal to 0 over negative 5. Remember, OK is going to be 0. So to graph that, I have 0 on my number line. It is greater than or equal to, so it's a bracket shaded to the right. The arrow represents positive infinity in this case, so my interval notation would be brackets with 0, and then the infinity always has parentheses. Okay, our steps for solving a linear inequality is going to be the same steps that we used for solving equations. The only difference is to make sure that when you multiply or divide by a negative, that you reverse the direction of the symbol. So step 1, simplify each side separately. Step 2, isolate the variable term on one side. So cancel the variable from one side if it's already on both. Get rid of anything else that's next to your variable term. And then step 3, isolate the variable, which means get x by itself. Alright, so in example 7, we'll go ahead and practice those steps. So step 1 is to simplify. So I can combine like terms on the left side. Negative 6 plus 1. Negative 6, positive 1. That's going to be a negative 5. So 7x minus 5. I'm keeping my symbol because I don't switch it unless I multiply or divide, and right now I'm just simplifying. And then 5x minus 1x is 4x plus 2. Alright, so I'm going to get my x term by itself, so I need to first subtract the 4x from both sides, so I cancel the x from one side of the equation, or inequality. So 3x minus 5 less than or equal to 2. Now I need the 3x by itself, so I need to cancel my minus 5, so I'll add. That leaves me 3x is greater than or equal to 7. And now my last step is to get the variable by itself. So divide by 3. I'm dividing by a positive, so my symbol still is a greater than or equal to 7/3. Right, so I'll graph this. Seven thirds is going to be the same thing as 3 goes into 7 2 times, which is 6, or a remainder of 1. 2 and 1/3. So it's going to be a little bit after the 2, before the 2.5. So that's 7/3. Greater than or equal to tells me it's brackets, and it's shaded to the right, including the 0. So then my interval notation would be 7/3 to positive infinity. Alright, so for example 8, remember a minus in front of the parentheses tells me I need to distribute a negative 1. So I have negative 15 minus 2x, negative 1 times 1 is minus 1. Distribute my 4 on the other side, so 4x minus 4, bring down my minus 3x. So now I can combine like terms, so I have a negative 15 minus 1. Negative 15 minus 1 is also a negative, so there's negative 16 minus 2x. And I have 4x minus 3x, so 4x minus 3x is 1x minus 4. So I can cancel my x by subtracting it. Remember, this is the same thing as a minus 1x, so bring down my negative 16. Negative 2 minus 1. Negative 2 minus 1 is a negative 1, so it's going to be negative 3x. Bring down your minus 4. Don't forget to bring down the sign with the 4. So now I need my 3x by itself, so I'll cancel the 16 by adding it. Negative 3x is greater than or equal to negative 4, positive 16. So 16 minus 4 is positive 12. And then divide by negative 3. When I divide by a negative, I need to flip my inequality around so that x is less than or equal to negative 4. Okay, so less than or equal to is brackets shaded to the left. Okay, so my interval notation would be negative infinity to negative 4. For example 9, we're going to continue solving inequalities and practice graphing them. So again, the balance line is where our inequality symbol is. We need to clear the parentheses first. So remember, when you're distributing the 3, you're distributing it with its sign, so that's like a negative 3. So negative 3 times n is minus 3m. And negative 3 times negative 1 is positive 3. And then distribute the 2. So 2 times m plus 2 times 3 is 6. Bring down your plus 1. Now we can combine like terms. So we have 5 plus 3 is 8 minus 3m. and then 6 plus 1 is 7. Alright, so now we can cancel the m from the right side, so minus 2m on both sides. So that's 8, and then negative 3 minus 2 is negative 5m, and then bring down your plus 7. So now we need the 5m by itself, so we're going to cancel the 8 by subtracting it. Negative 5m is less than 7 minus 8. 7 is a positive, 8 is a negative because you're subtracting. So 7 minus 8 will subtract them, and that gives me negative 1. Then negative 5 times m, so the opposite is to divide. Okay, and then at this point I say, oh, I'm dividing by a negative, so I need to reverse my sign so that it's the opposite direction to greater than. So then m is greater than positive 1/5, because negative divided by negative is positive. Okay, so we will graph it. Positive 1/5 is going to be just after 1 whole, and it's greater than, so it's parentheses shaded to the right. The arrow represents positive infinity, so then my solution in interval notation would be 1/5 to infinity. Alright, so for b, I need to distribute first. So 1/4 times m is 1/4 m. 1/4 times 3, remember 3 is the same thing as 3 over 1, so it would be 3/4 plus 2. Distribute the 3/4, so that's 3/4 m. 3/4 times 8 over 1. I can cross reduce, so that's a 1 and a 2. 3 times 2 is 6. Okay, and so at this point I may want to go ahead and clear the fractions. So I'm going to multiply everything on both sides by the common denominator, which is 4. So this is like multiplying by 4 over 1, and I'm multiplying it on both sides. So 4 over 1 times 1 over 4, the 4's cancel, so it's just m. And then 4 over 1 times 3/4. The 4's cancel, so that's going to be 3. 4 over 1 times 2 is 4 times 2, which is 8. And then on this side, 3/4 times 4 over 1 is 3. And then 6 times 4 is 24. So notice when you multiply by the common denominator, you will have no fractions. You'll just end up with all integers. Alright, so I can simplify. 8 plus 3 is 11, so I have m plus 11 is less than or equal to 3m plus 24. Subtract 3m from both sides. Remember, m by itself is a 1m, so I have 1, and negative 3. So 1 minus 3 is negative 2m plus 11 is less than or equal to 24. Subtract 11 from both sides. Negative 2m is less than or equal to 13, because 24 minus 11. And then we'll divide by negative 2. So as soon as I divide by the negative, I need to switch my sign around. So now it's greater than or equal to. So m is greater than or equal to negative 13 halves. So to graph that solution, okay, 13 halves is 2 goes into 13, 6 times 6.5, so negative 6.5. And it's greater than or equal to, so it would be brackets going to the right, to the greater side, including the arrow, which is infinity. So my solution would be brackets negative 6 to infinity. In the next example, we'll have 3-part inequalities, which are like the ones we talked about before that are the between statements. So when you have a 3-part inequality, it's written so that the symbols point in the same direction and towards the lesser number. So notice that my symbols are both facing the same way and they're both less than. So when you put your numbers are going to go in least to greatest in your answer. Okay, so if your answer was 3 is less than x is less than the next number, the last number would have to be bigger, 8. Okay, so you would not have this. That doesn't make sense because they're less than symbols. Okay, so it's always less than, and it's always least to greatest when you have your answer. Alright, so on example 10, we are going to solve the following 3-part inequality. So I rewrote it just to give myself a little bit more space. We're going to solve it using the same steps, but you have to solve it as 2 problems at the same time. So whenever we add, we're going to add to both sides of our balance lines. We want all 3 parts to balance. So I have 3x minus 1. I want the x by itself. So I'm going to cancel the minus 1 by adding. When I add 1, I'm adding it to all 3 parts. So it cancels in the middle. Bring down my 3x. And then 2 plus 1 is 3. 8 plus 1 is 9. Then working from the middle again, because that's where my x is. That's 3 times x, so the opposite of multiplying is dividing. And we're going to divide all 3 parts. So x is in the middle. And 3 divided by 3 is 1. 9 divided by 3 is 3. So my solution is 1 is less than or equal to x less than or equal to 3, which means the same thing as x is between 1 and 3. So when you graph it, you're going to graph x between 1 and 3. And then 1 and 3 are in brackets because of the inequality, it has an equal sign. So then your solution in interval form would look just like your graph, brackets from 1 to 3. Okay, and example 11, we're translating statements into inequalities. Use x as the variable. So A says the total cost is less than $10. So the total cost is x is less than 10. B, Chicago received at most 5 inches of snow. So x at most means that 5 is the most, so it's 5 or less. So less than or equal to 5. The car's speed exceeded 60 miles per hour. So the car's speed is x. Exceeded means it was more than 60 miles per hour, so greater than 60. And you must be at least 18 years old to vote. So age is at least 18 means 18 or older. So greater than or equal to 18. Always think about whether that number is included or not. So if it's included, make sure you have the equal sign under it. If it's not included, if it's strictly more or strictly less, then you leave off the equal sign at the bottom. Alright, Maggie has scores of 98, 86, and 88 on her first 3 tests in algebra. If she wants an average of at least 90 after her 4th test, so at least means 90 or higher, so greater than or equal to, what score must she make on her 4th test? Okay, so to start writing our equation, we first need to think about what it means to average. If you're finding your average, you're adding up all your scores and then dividing by however many scores you have. So we're going to start setting this up by writing 98 plus 86 plus 88, and then she's going to have 4 tests, so plus x is her 4th test, and we'll write x because we don't know what that test grade is. Divided by 4 is, we want it to be at least 90, so greater than or equal to 90. Alright, so now we will solve this inequality. So to solve it, we're going to simplify first, so I can combine the like terms in the numerator of 98 plus 86 plus 88. Okay, so that's 272 plus x divided by 4 is greater than or equal to 90. Alright, so now remember, if you have something divided by 4, to cancel that division, we're going to multiply by 4 on both sides. So the 4's cancel, and I'm left with 272 plus x is greater than or equal to 360. And then to get x by itself, I need to cancel the 272. So I'll subtract it. So x is greater than or equal to 88. Okay, so she must make 88 or higher on her test to have a score of at least 90 average. Okay, example 13. A rental company charges $10 to rent a leaf blower plus $7.50 per hour. So we have $10 plus $7.50 per hour, so times the number of hours. Marge can spend no more than $40 to blow leaves from her driveway and pool deck. So when we look at no more than, that means she can spend up to $40, but not more than that. So she can spend less than that and up to 40. So that's going to be less than or equal to 40. What is the maximum amount of time she can use the rented leaf blower? Alright, so my equation is basically what I wrote up with my problem. So $10 plus $7.50 per hour must be less than or equal to 40. So we'll subtract 10 750 times x is less than or equal to 30. And then 750 times x, so the opposite is to divide. So x is less than or equal to, okay, so when I divide 30 by 750, I get 4. So that means that she can rent the leaf blower for 4 hours or less. So if it asks what's the maximum amount of time, the maximum amount of time she can rent it for is 4 hours.